these guys. I tell them, hey, I want to sign up on your website, and these are my username, Harkirat, and password, which could be, let's say 123 123. I send this information over to Facebook, and Facebook stores this information somewhere. Now, what this somewhere is, we will get to eventually. This is what is called a database. We haven't discussed databases yet, so we are going to ignore databases throughout today's discussion. But what happens when I go to this website? I send an HTTP request from my browser. Facebook says, okay, you are signed in. Now, more things happen in case of Facebook. They send you an email, you put the OTP from the email on the website, and only then does it allow you to sign in. Facebook, Google, any of these websites will, make sure you are, verifying an OTP from your phone number or, email, things like these. They're not as simple as the application that we're building today. For us today, we don't really verify the user's email. So, if they give us an email like harkirat@google.com, we won't verify this email. How to do verification is a whole different game. For us, we will just believe the user. If they say I have this specific username or email, we will accept that email as such, and we will sign the user up on our website. Now, the user can sign in. They will have a similar page where they have a username and a password. They will send a request to our backend server, or in case of Facebook, you send a request to the Facebook server. The request looks very similar. You send a request to /signin. You give your username and the password that you remember to your account, and Facebook somehow again from the database, which you don't worry about, but somehow from this database it verifies, this is indeed Harkirat. Their username and password are correct, and it returns you a token. This part is new. This part is important. This is the thing that you need to learn about. Okay, when you sign into facebook.com, when you send them your username and password, they return you back a token, and this token is what represents / is what you need to keep very safe. And this is how you identify yourself to the Facebook servers in the future. I repeat, this token you somehow store in your browser somewhere. And now in every subsequent request that you are sending, every subsequent request, for example, show me all of my posts, a get request to see all of your Facebook posts. In all of these requests, you send over the token to Facebook. That is how Facebook knows that this is indeed Harkirat, because this token was issued to Harkirat when they signed in. So when you are signing in on a website, whenever you send the request, send your username and password, the server returns you a token. You store this token in your browser, and in every subsequent request, be it to get your posts, be it to send a message to a friend of yours, you send across this token. That is how Facebook knows that this is Harkirat. This token is something you need to keep very safe. I don't know if you've tried, but if you have a friend in college, you get access to their laptops, you can steal these tokens from them, and then you can log in as them as well. This token is the only thing that tells Facebook that this is Harkirat. So if this token gets leaked, or if you take this token and put it inside Postman and try to send a request to Facebook, that request will still be authenticated, because even from Postman, you are sending away that token. So this token is what stores your information and gives you persistent sessions. I repeat, what does it give you? It gives you persistent sessions. You log in once, the website is open for you forever until you log out. How does this happen? Because only once you send a request to the server, it returns a token to you, and then you keep sending that token again and again. This is similar to how you open a bank account with a bank. You first go to the bank and give your information. This is similar to signing up. You KYC in the bank. The bank gives you a checkbook. For Indian folks, probably understand checkbooks. It's a physical book that you have, and then anytime you want to send someone money, you sign a piece of paper that says I want to give my friend 200 rupees, and you send this over to the bank. The bank verifies it and actually debits the account. That is how the bank identifies you. The signature on the checkbook is how the bank identifies that this is exactly Harkirat. Similar to how this token is how Facebook verifies that this is exactly you. So just how Facebook returns you back this orange token over here the first time you sign in. Every time you sign in, sorry, not the first time you sign in. Every time you sign in, they return you back a new token. Similarly, if you go to a bank, the bank will give you a checkbook. And now in every subsequent request to the bank, if this is the user, every time I want to debit some money, send a friend of mine some money, I sign something from this checkbook and send it over to the bank. That is how the bank knows that this is indeed Harkirat. Let me remove 200 rupees from their account and send it over to someone else. So just like the bank gives you a checkbook every time you request it, a server, a website gives you a token every time you sign in, and you have to keep this token safe, just how you should keep your checkbook safe. There are nuances here, of course. If your checkbook gets stolen, it's not a big thing. Versus if your token gets stolen, then your account is pretty much gone. So this is a general workflow for authentication. On the left, you see, app.100xsteps.com. Notice first there's a sign in page. You send your username and password. The backend somehow verifies and returns you a token. Now, in every subsequent request, the request is being sent to the same endpoint. Doesn't matter if you are visiting the website or I am. When both of us go to app.100xsteps.com, this website, we both send the same underlying HTTP request. We are both sending a request to /courses, but I send my token. Your browser sends your token. That is how the server knows that this is Harkirat's account or this is Raman's account, and it checks what all courses has Raman purchased, and based on that you get back, let's say 3 courses or 5 courses or 1 course over here. So even though we are all sending the request to the same endpoint on app.netextsteps.com, the server identifies you using this token, and it returns you only the courses that you have access to. If you go to app.netextsteps.com, it is the same page, my dash courses. I'm sending a request to the same page as you, but I am getting back different data. You are getting back different data. The server is making sure, okay, when this request is coming, Harkirat is sending me some token, someone else is sending a different token. The server is checking. It is the server's job to ensure, okay, who is sending the request, and based on that, you see more or less courses. If you want to see the token, go to the backend server. If you click on the network tab over here and refresh this, refresh app.100xsteps.com, you will see the request that goes out. If I scroll down a little, in the request headers, I send something called the cookie. I'm not showing you the whole thing, but as you can see, there is this token over here. There are a bunch of tokens stored in the cookie here. What is a cookie? We will get to. But this token that you see over here, this very long thingy, is what I'm sending to the server. And the server is understanding this is Hakirat, sending me back my courses. If I somehow tamper this token, delete this token, then the server will stop to send me back my courses. They'll say you are not logged in. It will redirect me to the login page, or it will send me an empty set of courses. Cool. That is how authentication happens on websites. Even on mobile apps, it's fairly similar. You send a request to log in, you get back a token, you store it somewhere in the mobile device, or in the application storage. And then in every subsequent request, your mobile app sends a request and sends the token along with it. The server responds back with your courses. Do we understand this flow? The user comes to your website, the user sends a request to sign in. Of course, there's a sign up step before that is easy. When the user signs in though, they give you your username, your password, you identify them, you make sure the user name and password is correct, then the user gets back a token. In every subsequent request, the user sends the token to identify itself to the backend. This is to ensure that in every request I'm not sending my username and password. एक बार मैंने भेज दिया username and password. Once I've sent it, give me back a temporary token. Even if this token gets leaked, it is fine. Only this website got compromised. If I were sending username and password in every request, that will be super tedious, right? We can still do that. We can be like, यार हमारा backend दो. Our backend expects you to send username and password in every request. That's a little ugly, right? Because if the username and password gets leaked somehow, then it's a huge problem because you'll be storing the username and password in the browser. Versus this token, if you're storing in the browser, if it gets leaked, it's fine. You can ask the backend server to revoke it. You can log out from that device so the token gets revoked. You can do things like this. So that is why this process is chosen versus always sending your username and password to a backend. Do we understand the basics of authentication? How is authentication done, in a full stack application? I think 91% is great enough for us to move on. But I'm curious and happy to love to talk to 10% what felt weird here. But I think 90% is great. Let's move on and finish the whole thing. And then happy to take doubts. Alrighty. Now comes the coding bit. As always, guys, if you want to follow along, you can follow along. If you want to just see me code, that is fine as well. If you want to code yourself after the class, that works as well. Either way, I'm now going to create a basic backend application. I'm going to create this thing right here that is going to support these endpoints. An endpoint where you get user and password and somehow store the user somewhere, not in a database. We haven't yet learned about MongoDB, Postgres. So we will not store this data in a database. We will somehow store this data in a in-memory variable or users array basically. Return the user a token. Every time the user sends a request, we validate their token and only return them their information. We make sure, a user can only ask for their own information and not for someone else's information. This backend is what we're going to code next. Prerequisite is going to be Express. So if you don't know Express until now, if you don't know Express, that's fine. If you don't know middlewares, it's okay. We'll get to middlewares eventually. But basics of Express you need to know. We've covered them until now. So, hopefully you've gone through these classes. Cool. Let's initialize an empty Node.js project. If you want to run ahead of me, feel free to run ahead of me. Again, let me post slides one more time for people who have just joined. These are a link to the slides, and I'm just following slide number 4 over here, trying to create my project. Let me open the instructions on the right. Let me open a terminal on the left. What is step 1? Every time you want to, sorry about that. Every time you want to create a fresh project, creating an empty folder for it. That is going to be step 1. So let me go to my projects folder over here. In my projects folder, let me go to the cohort 3 folder over here. In my cohort 3 folder, I'm going to create a fresh project, call it week 6 authentication. Then I'm going to go into this week 6 authentication folder. That was step 0, I guess. Step 1 is initializing an empty package.json inside, initializing an empty Node.js project inside. How to do that? npm init-y to initialize an empty package.json. As you can see, it says wrote to this specific file. It wrote all of this content into an empty package.json file. That is step 2 or whatever, step 1 over here. What is the next step? It is to create an empty index.js file and open the project in Visual Studio Code. So let me first open the project in Visual Studio Code. This is the directory where my project exists. I'm going to go to Visual Studio Code, file, open, and open it in Visual Studio Code over here. Create an empty index.js file. Cool. Step 1 and step 2 here are done. Step 3, adding Express as a dependency. I'll take a 15-second break. So, if people are following along, just open the project in Visual Studio Code. To recap, what have I done? I created a fresh folder, created an empty package.json by running this command, created an index.js file. You can run this command to create it as well, or open it in Visual Studio Code and then right click new file, index.js to open it. All right. Next step is adding Express as a dependency. So open a terminal, new terminal, and run npm install Express. That will bring Express as a dependency to your project. How do I know this is done, Harkirat? You will see in the file structure on the left, a new node modules folder is created where a bunch of dependencies came along with Express over here. Next step, create 2 new post routes, one for signing up and one for signing in. Here you need to be a little comfortable with the Express library that we have learned until now. How do you create 2 new post routes? First, you import the Express library, const express equal to require express. Then you create an app instance, const app equal to express. The Express library exports you a function, and this function is what you call to create an instance of this app variable. You can call it anything. You can call it, Express app if you want. But the point is, Okay, the express library does not return you a variable. It returns you a function. You call that function to create your HTTP app, which is what we have done here. What do we need to add? We need to add two post route handlers. Okay, anytime a request comes to /signup, then we need to handle it over here. And anytime a request comes to /signin, then we need to handle it over here. Try to write this code yourself, or copy, either is fine, and try to have this code locally. If you want it to be a little bit cleaner, you can do something like this. Sign in handler, and define this separately. Okay, this sign in handler is defined separately. And I will write all of my logic over here. If you want, you can move this to a different file also, but let's not go there. app.post /signup. Anytime a request comes here, this function should get called. Anytime a request comes to the /signin endpoint, then this function should get called. This also I can move outside if I want, or you can move it directly over here. You don't need a name for it. It can be an anonymous function if it is directly defined over here, because you don't have to call it ever. You just have to put it over here. Two endpoints have been created. Lastly, app.listen 3000. What did this last line of code do? It would ensure that the HTTP server is listening on port 3000. Anytime a request comes to localhost 3000, it will be handled by this app instance, which has two routes right now, a sign up route and a sign in route, both on the post method. Empty routes we have right now. Let's try to run it locally and see, does it work already? Let me run node index.js. And when I run node index.js, notice the process sort of hangs. It does not immediately exit. The answer is this line of code, because it is constantly listening on port 3000. Anytime a request comes on localhost 3000, if I send a request on localhost 3000, it gets handled by this server. Now I don't have a get handler over here, which is why it says cannot get /. But if I go to Postman, I repeat, if I go to Postman over here, which is another client for HTTP, it lets you send HTTP requests. If I go to Postman and send a request to /signin, a post request, then you will notice it remains hung. This request remains hung over here, does not get back a response. Why is that? Because I have not returned any response over here. I did not write rest.json message, you have signed up. I have not written this, which is why this is hung. If I would have written this, then this request would have gotten back a response. The app seems to be working fine correctly. And let's try to finish the rest of the steps and have a very basic version of an authenticated application. These steps are done. This step only expects you to create empty route handlers for now. Slowly we will add in the logic. Next step is use express.json as a middleware to parse the body. Whenever you use a post endpoint, you don't get access to the request body. Here, what is the request body? If I go to Postman, whatever I send in this body over here, which for our users is going to be their username and password, I will not be able to access this username and password over here in const body equal to rec.body until I use the express.json middleware, something we discussed last week. Okay, the express.json middleware will help you parse any post body that comes from here. So this is the post body that came. It will get parsed only if you have this express.json middleware. That is what I've added over here. Create an in-memory variable called users, where you store the user's username, password, and a token. We will come to what this token is later, but for now, create a global variable, which is an array. And anytime a user signs up, anytime a request comes over here, we store it in this users array. This is because we haven't learned about databases right now. We will be learning about databases in 2 weeks, maybe a week from now. Then we will store this data somewhere else. For now, we are storing it here in a in-memory variable. That is what this const users equal to empty array is going to be used for. Complete the sign up endpoint to store the user's information in the in-memory variable. Complete the sign up endpoint. कि whenever the user comes to this page on your website, whenever the user comes to this page, the create new account page. Now Facebook expects 10 different things from you. We only expect 2 things from our user. Username, password.
.60 miles per hour.